Okay, now here we have a pretty tricky one because, um, a substitution doesn't seem like it'll work. And if you think about doing integration by parts, you really, well, it's a composition of functions, but you might think to do something like, because it's just one function, maybe letting u equal to e to the square root of x, and then letting dv simply equal to dx. Now, if you actually go through and do this, what you'll get is a huge mess that keeps getting worse and worse and worse. So I'm going to let you try that just for fun and mess that up. But this doesn't actually lead us to finding that integral. And actually, the best thing we can do is to do a substitution first. Now, this is something that you might want to keep in mind when you have a lot of times when you have a root, just square root of x or square root of t or something like that. It helps to just get rid of that by doing a substitution. Now I'm going to use w because we've been using u and v for integration by parts. Now let's say I let w equal to negative square root of x. And the goal with this is to just get rid of the negative root x so that I just have a w there. And hopefully that'll simplify things quite a bit. And so then dw is going to equal to negative 1 over 2 root x dx. And so then what I can do from this is that this tells me that dx is going to equal to negative 2 root x dw. And what I can do is I can substitute that into there. Now, notice I'm not going to want to have any x's there. And I have this extra root x here. But remember that w is equal to negative root x. So then basically what this turns into is that dx is equal to 2. If I take a look at this negative root x, that's simply w dw. So what this allows me to do is I can swap this for a 2w dw. The negative root x is going to be my w. Sorry about that. And then, so then my entire integral is going to be the integral of, I'm going to put the 2 outside, and then w dw, and I'm leaving a little space there for e to the w. And you might recognize this because this is a integration by parts problem that we've done before. I mean, this is just my variable w times e to the w. And now this isn't too bad, right? So what I'm going to choose for this is I'm going to let u equal to w. I'm going to let dv equal to e to the w dw. So then what I'm going to get is du is going to equal to dw. And then v is going to equal to e to the w. Okay. So then I do this now. Don't forget about the 2 that I have right there. But so then if I do integration by parts, I'm going to have 2 u times v. So that's w e to the w minus the integral of v du. So v du is e to the w dw. Now you might have noticed I missed something. What is it? What did I miss? 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 Anything? Well, if you said a 2, you were right. Remember, I've got this 2 is in front of multiplying the entire integral. So although I wrote 2 here, I also need to have that 2 there. All right, so that turns this frowny face into a smiley face. Okay, so nice work. All right, so then what I get is this is equal to 2w e to the w minus 2 e to the w. And last but not least, I can substitute back in what w is. Don't forget your plus c. And then, so this is going to equal to, so remember w is equal to negative root x, right? So this is going to equal to negative 2 root x, e to the negative root x. And so then this is going to be minus 2 e to the negative root x plus c. There we go. Nice work.